Today, I'm going to talk about experiment A2 graphical method. In this experiment, we are going to find the resistance of a resistor using graphical method. So the objective for this experiment is to obtain the unknown resistance Rx using a plot of known resistance against the measured current. So the materials and instruments we are going to use include battery of 6 volt, ammeter which can measure a range of 0 to 30 milliampere, voltmeter 0 to 10 volt, digital multimeter, switch, a resistor, a variable resistor, and also connecting wires. So next, I'm going to talk about what are the procedure we are going to have for this experiment. So as you can see from the diagram here, the circuit is made up of a 6 volt battery, a milliammeter, a variable resistor, and also an unknown resistor Rx. So at first, we need to fix the current to 10 milliampere by adjusting the variable resistor. Then, we need to add another variable resistor which is placed in series with the first variable resistor, and the resistance for the second variable resistor can be varied in steps of 100 ohm from 100 ohm to 1000 ohm, and the corresponding current recorded by the milliammeter will be recorded in a table. Next, the second variable resistor is removed and replaced with an unknown resistor Rx. And for this case, we need to measure the resultant current through the milliammeter. And from the recorded data, a graph of current against the resistance is plotted. And the value of the resistance for the unknown resistor Rx is determined from the graph by using the generated equation shown by Microsoft Excel. So as you can see here, these two diagrams representing the simulation for the circuit in this experiment. So the battery here will be equals to 6 volt, and this will be the digital multimeter which will be recording the current flowing in this circuit. This potentiometer will be the first variable resistor, and for this will be the second variable resistor. According to the methodology, the resistance for the second variable resistor will be varied from 100 ohm to 1000 ohm. So the current flowing in this circuit will be recorded using the digital multimeter. And hence, for the second step, we need to replace the second variable resistor with an unknown resistor Rx, and the resultant current flowing in this circuit will be recorded using a digital multimeter. So the data obtained will be recorded in a table and will be plotted in a graph. These are the results I obtained by using the simulation. So as you can see here, when the resistance for the second variable resistor is being increased from 100 ohm to 1000 ohm, the current is decreasing from 8.58 milliampere to 3.75 milliampere. So according to Ohm's law, when the voltage is constant, the resistance and the current will be inversely proportional to each other. So this is the value of current I can obtain when I have inserted the unknown resistor into the circuit. The current recorded is 5.78 milliampere. This will be the graph for current against resistance, and this will be plotted using Microsoft Excel, and the generated equation is shown here with R squared equals to 1. So in order to find out the value of unknown resistance Rx, so I need to solve this equation by using Mathematica. And the answer provided by Mathematica is 430.912. So in order to make it shorter, so I will summarize the value for Rx will be equal to 431 ohm. And for the percentage of tolerance, I have to use the difference between the measured value and also the experimental value. But for this, I will only take the positive difference and divide it by the actual value times 100%. The actual value for the resistor is obtained by using the colored code. So according to the color code, I have do my calculation, and the value I got is 440 ohm, and for this case I got 431 ohm. So the difference between two of them is 9 ohm. So by substituting the value into this equation, I can get a percentage of tolerance of 2.05%. Okay, I think that's all for my explanation, and thanks for watching.